Hi guys, let's solve today's Leetcode problem, and it is problem number 2615, sum of distances. Okay, so let's read this problem. What does it say? You're given an zero index integer array nums. There exists an array of length nums of dot length, where array of I is sum of mod of I minus j all over j, such that nums of j minus is equal to nums of I and j is not equal to I. If there is no such j, set array of I to be 0. Okay, so this is the problem. Let's understand the problem and look at the example as well, and at the end we have to return that array. So if you see this example here, the array is 1 3 1 1 2. Okay, now if there exists an array. Okay, so this is, let's say, array initially 0 0 0 something like that. Now what question says is that where array of I is sum of mod of I minus j all over j, such that nums of j is equal to nums of I and j is not equal to I. So now if we calculate for this index, that is 0, we need to find in this array all such indexes which is equal to this value. Basically, if this is I have to find all such j in the remaining part such that it is equal to nums of I and j is not equal to I. So I mean, we are not taking this I, so yeah, remaining part of the j. So here if you see, for this I, this is the one where it is equal, this is another one. Now similar, so we will calculate at for I equal to 0, nums of 0 is equal to nums of 2 and nums of 0 is equal to nums of 3 also. So now we have to take sum for all of this, with their absolute difference between their indexes. So this is one absolute difference, that is between 0 and 2. Then there is another absolute difference between 0 and 3, because they are same. So altogether sum is 5. Okay, now let's discuss for index 1. Now if my index is, let's say here, this is my I. Now for this I have to calculate, I have to find all j in this entire array where I is not equal to j. So leave except this place, all the places I have to see if there is this value 3 or not. So I see there is no value 3 in this array other than this, right? So for that reason this value becomes 0. So this was 5, this became 0. Now let's see for index 2. For index 2, this is index 2. Here again this is our I, this is I, and for this entire thing this foot should be our j. We have to calculate the absolute difference between their indexes and sum of all such indexes. I mean, sum of all such absolute differences. So leaving this I see there is this one which is equal to this current index value. There is this another one. So similarly we will calculate nums of 2 is equal to nums of 0 and nums of 2 is equal to nums of 3 as well. Therefore array of 2, what it would be, absolute difference between their index, that is 2 minus 0, and 2 minus 3 is equal to 3 here if you see. Okay, so similarly we will do for 3 and 4 as well, and this will be our answer. So now if you see and constraints also, if you see, constraints are nums dot length is 10 to the power 5 and nums of I is less than equal to 10 to the power 9. So yeah, what we are going to cover as part of this problem is, one is the brute force approach and another is optimal, which will be mostly related to maths. So I mean, in brute force also, you see there is two things that we can do. One is for every index, let's start with this index, I iterate over entire array and see if there is any such index with the same value as this one, and if there is, I will just add absolute difference into my answer, and altogether that would be my final answer. So this is the ultimate very brute force approach. So what I would do is, I'll just quickly write for I is equal to 0, till I less than n, and this will be my sum, that absolute difference sum, which will be 0. Now another loop would be from 0, j is equal to 0 till j less than n, and I would have this check if I is not equal to j and this nums of I is equal to nums of j. If this is the case, then sum plus equal to j minus I can write it as absolute of j minus I, and once I have calculated this, so my answer of I would be sum. So this is the ultimate brute force approach, but there is one problem in this, that this loop basically runs this is one loop, this is another loop, so altogether nums dot length can be up to 10 to the power 5, so this will be 10 to the power 10, which won't pass, so we won't consider this approach. Now what is next thing that we can think of? So if you observe carefully here, that this nums that we have given, we all we need to, basically we don't need to, for if I'm here at 1, I don't need to know the index of 3 or 2, I just need to know wherever the value was 1. So can we just think in grouping them in some way? Okay, so how can we group them? So let's say there is this value 1, we have some sort of map data structure where this would be our key, and we will have list of indexes. So a key would be actually our value for which we are looking. So if we just pre-fill this map, so how it would look like is 1 is at this is the value which is at index 0, then I see 3 is at index 1, then I see 1 again, so this is at index 2. Since this is a list, I can append the values over here. Then I see index 1 is again, value 1 is again at 3. Now I see 2 which is at index 4. So this is our map. Now what we can do is, in this map we can keep on iterating. This is what my map has been created. Now what I can do is, for every value, for every I, this was our I, we were for this I we were going all across this entire array to calculate this sum. But now if you see this one, right, since we have pre-filled our map, we don't actually need to iterate over all the values in the map. Rather what we can do is, first loop will remain same, I is equal to 0 till I less than n. Then what we need to do is, we'll again have this sum as 0, and this is our map in which we would be going to iterate for this particular value. So I can keep it as index is equal to this is nums of, my bad, mp of nums of I. Okay, so nums of I is 1 in this case, so mp of nums of I will be, basically we are iterating for this value, this is 1, right? This is our nums of I here. For this value I see, okay, it's there in map, and this is the list, so I'll be iterating for this value in the list. So what I can do is, this is the value, I can simply sum up. I since these are the indexes only, and I want the sum of these indexes, so I can simply sum this absolute of my index I minus index, and at the end same thing I would do. My answer of I would be sum. Okay, so this is the approach. So if you see, for this problem we have written the approach, but the thing is that for this I1, we are going over this and computing the answer. But if you see this nums, right, here for this one we will again go in this list and then find answer. For this another one we will again go and find answer. For this another one we will go and again find the answer, right? So if let's say there would be some array saying, you know, 1 1 1 1 and so on, till as our constraint is, you know, nums dot length can be 10 to the power 5. So every time we are on this list here in map itself would be of 10 to the power 5, right? Due to this reason all values are same. So eventually we will end up, you know, having 10 to the power 10 time complexity with the current solution. That's why this won't work. And though we can say, like, you know, time complexity in worst case it will go to 1n square. Space complexity, we have taken a map to store all the values, and it will store at the end O of you know, all elements itself, so it will be O of n. Yeah, so this is the approaches. Now we can discuss like the optimal approach here. And optimal approach is, you know, it needs some thinking. And this map that we have created, right, instead of here iterating over each element one by one and then having this list and computing the answer, we need to think something in this direction that can we iterate over this map itself for this value, and since we have this indexes over here, so can we compute, you know, our final answer just iterating over this map once for each element. So in total that would be of n, right? So I'll just explain how we can, you know, do that. So okay, so now let's try solving this problem optimally. Here I have just written the map how it would look like. Now instead of going over, you know, all elements one by one, rather we would iterate over the map. And for every element, we this map stores all the indexes where this has occurred, basically where one has occurred. So we will try to calculate value for each of these indexes, just going over this array only once. I'll just write this list over here. For one, we have all its indexes where this one has occurred is 0, 3, and these indexes are 0, 1, 2. Now, if you see what is the total sum for this array, that is 5. And what we need to calculate is we need to calculate for each of these indexes, right? So when I'm at index 0, I need to calculate you know, my total sum. Total sum is how it looks like, that sum of all the values j minus 1, sorry, j minus I, and this is you know, absolute value. So this is how for each value it looks like. Okay, so sum is nothing but I would now like write this in mathematical terms, that sum is this is my, you know, answer of I can say that is something j is equal to 0 till m minus 1, where this is our j, okay, that we are iterating over, and the current value would be I, and this m is nothing but length of our array, length of one group, we can say that group that we have created, length of a group. Now what does this says, that it is sum of a of I minus a of j. So this is answer of I, you know, mathematically, uh, where I already told that j is variable here, where it is varying from 0 till m minus 1, and I is constant, which is basically the value which we are computing for current index I. And now if you see, can we you know, this entire expression can be written, since this is a mod value, right? If we directly write it like directly sum from 0 till m minus 1, it won't hamper our situation where we also say, you know, for all the values which it is equal, which is map is rightly handling, but it says j should not be equal to I. But here if we see if we are taking absolute values, so it will be automatically handled in this particular expression if you see, because a of I minus a of j, and where I'm saying is I is equal to j, so it would be like a of I minus a of I, which will be 0, right? So that's why we can directly do a total sum. But if we sort of divide this, or think like what it actually says. Now let's say for index 1, where value is, this array value is index, this index is 2. Now if I have to calculate, so for all this value which is in left side, okay, yeah, and all the values in right side. So for this index where it I would be 1, so for all its indexes in left, I know that this is the highest. So here I can write it as, something for left ones, I can write it as I minus j, right? But for because in order to calculate absolute, I'm just saying, now for these ones, if you see whatever is in right, these value would be greater than my I, right? So for that reason, right, I can say that if I write it something like j minus I, you know to have this absolute difference, then this would work. Now uh, let's you know uh, divide this expression in two parts. Okay, this is left and right concept I explained, but let's actually divide this in two part. Forget about this for a moment. And how we can divide in left and right? So this is my I, and I know that from this left would be from 0 till I minus 1. This is my I minus 1, and here it will be from I plus 1 till m minus 1, right? So this expression that I have written, it can be divided into two part, left and right, and here it is how it will look like. So j will go from 0 till I minus 1, same thing, I minus a of j, plus right half is j goes from I plus 1 till I till m minus 1. Okay, this is a of I minus a of j. So one thing is, this is our right half, this is our left half. Left plus right is total answer for that index. Now let's calculate this left and right individually. Okay, when we calculate left, it is left is from 0, j is equal to 0 till I minus 1. We are doing a of I minus a of j. Okay, here if you see, if we just simply divide it in these part, basically a of I and a of j, since I told for left half, if you see, I is always greater than all the indexes in j, in left side, which is j, right? So this can be simply divided as, because we have to retain the meaning for this mod. So meaning would be retained because a of I will be greater than a of j. So we can divide this directly. So j would go from 0 till I minus 1, and a of I minus, again sum of from 0 till a I minus 1, and then a of j. Okay, so here the value is how it is. Now here if you see, this is a of I that we are calculating, and here what in this summation what is varying is j. I is not varying, right? So which means this is a constant. Now how many times we want a of I to be added is from 0 till I minus 1, and 0 till I minus will be total of I times that we want to multiply a of I. So I can simply write as a of I into I. This many times I have to want to multiply, minus a of j, this second part. So second part is this a of j that we are calculating. um, what does this says? From 0 till a minus 1. So this says that in this array that we have from 0 1 2 and 3, this says, okay, sum this value from 0 till I minus 1. So this is summing this value. Okay, a of j is varying here. So can I say this is something like prefix sum till this value j? Okay, so it can be said. So I'll write this as a variable, prefix sum. Okay, this is a variable that I have taken. Uh, yeah, so here I can write as well that from j is equal to 0 till I minus 1, a of j, this value I am considering as prefix sum. Okay, now this is our left that we have calculated. Now let's calculate the right. So right here, if you see, this is our right. Okay, I'll just copy this part. Yeah, so now if you see right, for right also, here this is mod, right? Mod of a of I minus a of j. Now we have to retain the value, retain the meaning of this mod. So as I explained over here, you see that in right side I would be smaller and any index in right, that is j, would be greater than j, right? So that's why I have written it as j minus I. So that is why if we want to retain the meaning of this mod, this if I have to divide this in these two terms, it would look something like this: j equal to I plus 1 till m minus 1, a of j minus j equal to I plus 1 m minus 1, and then this is a of I, because a of I is higher index and minus smaller index, that will retain the absolute this value. That is why we did here a of j minus a of I. Okay, now let's see what this does this a of j means. Okay, so a of j, if you see, so A of j is basically summing up all the indexes from I plus 1 till m minus 1. Now I know that I would have this total sum of this array, right? Now if I have total sum, this is, let's say, my array with some sum. I have my total sum and this is prefix sum. Okay, let's say for index till index I minus 1. Okay, this is I minus 1, this is I plus 1. I know that till this is my prefix sum till I minus 1. Okay, and this is my total sum. I know total sum, and I want to calculate from I plus 1 till m. This is what I want to calculate. So if you see simple math, I can write, right, something like total sum is something but sum minus prefix sum. Now this is one piece which is also need to be subtracted for calculating this, you see. So this is nothing but a of I. Okay, the value in this array minus a of I. So this means we have calculated this remaining sum. Okay, so that is how it is. Minus, now this a of I is again we did, right? The here j is variable, a I is constant, so we want to multiply a of I how many times? Not multiply, we say we want to add a of I how many times? From I plus 1 till m minus 1 times. That is, these many times we want to multiply. And if we see, this total length is m, and to do sum till here, right? So this total length is m, and this length, if you see, I plus 1. So if I do minus I plus 1, so it would be m minus I minus 1. That is the remaining length. So I can do subtraction of m minus I minus 1 times a of I. So this is my right is calculated. This is my right. Above I have calculated my left. Now I can, my final answer of I would be sum of left plus right. Okay, let's just write these together. So left is a of I into I minus prefix sum. Okay, now add, let's add right. So right is sum minus prefix sum minus a of I minus m minus I minus 1 minus 1 into a of I. Okay, So let's solve this expression. Here I can take out sum is nowhere, so sum would remain like sum. There is 2 times minus of prefix sum, so I can write it 2 times prefix sum. Now this is a of I, and if you see a of a I times a of I, and I would write, so this is minus of a of I 1 times, so it would be I times a of I plus minus this one 1 time a of I. Now let's expand this, minus m times a of I minus minus plus I times a of I times a of I plus 1 time a of I. Okay, now this minus and plus this would get cancelled, and if you see what it is, 2 times a of I. So again same thing, sum minus 2 prefix sum plus 2I into a of I minus m times a of I. So if we just take the same thing, if we take a of I common from here, plus a of I would be 2I minus m. So this is answer of I. This is final expression that comes after doing this mathematics. Now we can, this is basically for every value we need to iterate in the map for basically each group for this index, and that would be our answer. Now let's proceed writing the code for it. Okay, so code would be, one is I need to have answer array created. So since our constraint was nums of I can be up to 10 to the power 9, and we are doing all this indexes sum, right? So length is do I, so will take long here, because it can go higher than 10 to the power 9. So this is answer, where it would be of length n, and initially we will make it as 0. And again same thing is that we will have our map created. So map would be something like ordered map of int comma vector of, this is my map, or maybe let's write it as group. So these are multiple groups that I'm creating. Now I'll populate this map with my current values from I equal to 0 till I less than n, and groups of this nums of I dot pushback I. So after this step, our map will be created with all the values, basically all the groups. Now we need to iterate on this groups. Okay, so for auto, let's take you know auto it on groups, and this groups is nothing but this is list of all the you know list of all the group. So I can I don't really need this value, I need only this list. So I can keep a vector of integer as an individual group, which will be from this map, second value in the map. Okay, so yeah, this is my group. Now I need to calculate the total sum as well for this group. So sum would be 0, I will just iterate in this array from 0 till this group dot length. So here, size equal to, let's say, group dot size, or I can keep it as m is equal to group dot size. Okay, till m. What I need to do is sum plus equal to group of I. I have calculated the total sum now. Now I will also keep one a prefix sum. Okay, because that we need, you know for calculating for all our indexes, value for all our indexes. Now we need to iterate in this group and find value for each of this index in this list basically. So we have calculated the formula over here. We will simply use the same thing. So our answer of what? So this is our group. In that example, we had, group as for 1 it was 0 2 3, right? So for this one I need to calculate answer. But what does this represent? This represents the index in current array that the initial array that we have. So this is my array group, and group of I is the index for which I am calculating answer. So answer of group of I is equal to the above formula. Above was what? Sum minus 2 times prefix sum. Prefix sum also we have calculated. Again plus a of I. Okay. So what is this a of I? A of I is again same thing. This value, right? So a of I is same thing. So group of I into, here you see, into 2I minus m. So I can write here as 2I minus m. M is already size that I've created, and I is uh, yeah. So I is, oh my bad, I didn't return the loop itself. Yeah, I is equal to 0 till m. Yeah. So yeah, this is our answer for each of this value in the list. I and this is, I mean, for each of these indexes I have calculated the answer and populated my answer array. And for further we need to calculate, keep computing this prefix sum. So prefix sum would be nothing but plus equal to group of I. Yeah, so this is how it is, and at the end we can return answer. Yeah, so this is all about it. It was mainly a mathematics problem. We needed to derive what it is and how is this impacting um, our final answer. But map part, I think that was easy enough. A little bit of maths, but yeah. Now let's discuss the time and space complexity for this problem. So time complexity, you see, going over this array n of n, then this going over this group, and inside if you see, we are going inside the list. Okay, so how many groups it would be in total? You see this, right? How many groups will be there in total? All the number of unique elements. And what this list will contain? All the indexes. So altogether if you see, so it's nothing like we iterating over the map, but altogether we are iterating, I mean, this iteration would be for O of n times only, nothing more than that. So it is O of n. And space complexity, for similar reasons, the map is storing all the indexes itself, so it will be O of n. So yeah, this is time and space complexity for this approach. And yeah, that's all for the problem. uh, I will add GitHub link for my code in description below. Thank you for watching. Stay tuned for next video. Have a good day.